Hi everyone, I'm sorry I can't be in class with you today, but I am going to leave you with this video so you can follow along with me and still learn what we had planned for today. So I'm actually starting with yesterday's notes. So if you want to pause this for a moment and go ahead and get that out, we had a few leftover things to finish. So go ahead and pause and get that out if you need to. So this is the sheet that we left off on yesterday. We had saw that if you have an x value or an input and you put that in to the equation, what you can get is a y value out of that. And that y value with the x value together created a coordinate. And then that xy coordinate can be plotted on a graph. And so far we've plotted these lines. The first one was something that we considered increasing, and the second one down here was one that we considered decreasing. And we said if the slope or the m value is positive, that's why it increases, or if the slope is negative, instead it will decrease. But there are some other key facts that you should know about. Now, we're not going to graph these lines any different than we did the ones that we just talked about, but I wanted to point out some different facts about these than the last one showed. So we would still evaluate in the same way, where we would go ahead and we would put in each of these values in for x. So you can see I'm always ending with +2, but I did change the starting value depending on which of these values of x we were using. And so if I complete all of these operations, I get 0, 1, 2, 3, and 4. Altogether, what these are going to do is they're going to create a coordinate set of pairs for us, x comma y. That's going to be -2, 0 for the first one, -1, 1 for the second one, and so on. 0, 2, 1, 3, and 2, 4. What I can do is take those coordinates over to the graph and actually plot them now. So if I plot -2, 0, that's left 2 and none up or down. Then -1, 1 is left 1, up 1. 0, 2 is none left or right, but up 2. And then we have 1, 3 in line with that, and 2, 4 in line with that. And what we're able to do with all of those dots is connect them together. So when we connect the dots using a straight edge, and you can borrow one from the drawer in the classroom up front if you need your own, we connect the dots and we can form our line. Okay, so we can go ahead and put arrows on the end because that would have continued if we did more than just the values from the table. So if I did anything less than -2 or greater than +2, it would have continued in that pattern. Now this line is going to look very similar to the next one we do with just one little difference. You might be able to notice the difference between the two equations that I gave you in question 3 and question 4. Question 3 has x plus 2, where question 4 has x minus 2. So when we go down to evaluate this one on repeat, we're taking all of these values that are in the x column of our chart, but we're going to subtract 2 every single time now. And when I subtract 2 every single time, I get different values for the y. First, -4, then -3, then -2, -1, and lastly, 2 minus 2 gives me 0. So we're going to get -2, -4, -1, -3, 0, -2, 1, -1, and 2, 0. We're going to go over and we're going to plot those. So -2, -4, that is left 2 and down 4. That'll be a point. Then -1, -3 will be left 1, down 3. And you can already see how they're lining up. That fits with 0, -2, which is just down 2 from 0, 0. And then we have 1, -1, and 2, 0. And once again, all of these are in a line. So we can use our straight edge, connect them together, put little arrows to indicate it would have continued on. And it is very similar to the one that we just did before. They're actually heading in the same direction because they have the same m value. So both of them were increasing this time. But that little difference at the end, the y-intercept or the b value, which we've learned about in the past, had the small difference here. This had a b-value of 2. So that meant it started at the y-axis at positive 2, whereas this one was minus 2 or negative 2, and that's why it started below the x-axis and hit the y-axis at negative 2. So what that tells us is if the y-intercept, or b, is positive, the line will intersect the y-axis above 0, 0, above the origin. But if it is negative, instead that line will intersect the y-axis below 0, 0. And so if you put this fact together with that fact that we looked over through yesterday, you kind of know in general what every line is going to look like. If you have a slope that's positive, it's going to go up or increase over time. But if the slope is negative, it's going to go down. If you have an ending number that's being added, like number 3 in this page, it's going to start above the 0, 0 value. But if it's minus 2, your graph will cross below the 0, 0 value, the y-axis. All right, let's just finish these two things up from yesterday, and then I will have a separate video for you to look at for graphing more lines, but in a shorter way than these ones. So these last two are special situations. You can notice here that this just says y equals 5. There's no x at all. So when you go to complete this evaluating section right here, all right, I'll put the 5. I don't have to put anything else. That's already y. I'll put the 5 again. There's nowhere for my 0 to go into. It's still 5. And then there's nowhere for the 1 to go. It's still 5. So literally, when y equals 5, that's what it means. Doesn't matter what the x is. Y is 5. So every single time, you get the y coordinate as 5. So if you graph something like this, that's -1, 5, or left 1 and up 5. And then 0, 5 would be just up 5. And then 1, 5 would be right 1 and up 5. And you'll notice they're connecting in a very particular way. They're connecting horizontally at that spot. And so anything that is y equals will be a horizontal line. So a horizontal line is written in the form y equals a number. The line will intersect the y-axis at 0, whatever number. In this case, that number was 5 every time. And the line will have 0 slope. It goes up and down 0. It just stays flat. Then you have the other situation here, where x is always equal to -4. And in a sense, that is opposite to the one we just did. X is literally always -4. So if you go to where x is -4, that happens here. Oops, let me erase that and get that a little bit clearer for you. X is -4 here on the x-axis, but it doesn't matter what the y value is. All we care about is that x is 4. And so this is the one and only type of line which is not a function, because when you connect those dots, that x value has been repeated over and over and over again. And so because that's not a function, we have a little bit of a unique situation. A vertical line doesn't even have a y equals equation. A vertical line is written in the form x equals a number. That will always intersect the x-axis at whatever number that is. And the line will have an undefined slope. Because it's not a function, we can't define what the slope is. It doesn't go anywhere left to right. It's just stuck in one place. Okay. That's all I'm going to show you for the stuff yesterday. If you'd like, you can go ahead and look that over a little bit more, rewatch part of the video. But I will show you a shortcut for graphing lines in the next one, which goes with the notes that the substitute should have handed you.